Hello, this is Farhan Shakil from the Republic 2.0, and I'm back with the physics past paper, which is 8 PHO from the Pearson edexcel May 2023. So first of all, in the part one of this video, I'm going to start with the multiple choices of this paper, P1, which mostly consist of the electricity and the mechanics. So first of all, we've got this question number one. And question number one says that a student throws a ball vertically upwards, which of the following shows a free body force diagram for the ball immediately after it leaves the student's hand. So since the student is, throwing a ball vertically upwards, and if he is throwing the ball vertically upwards, the only force acting on the ball is the downward, which is the gravity, right? So A cannot be the answer, B cannot be the answer because there is no upward force acting on the ball. The only force which is acting downward is going to be the gravity plus the air resistance, right? So that is why we have to go with the option number C. Similarly, for the question number two, which row of the table contains only scalar quantities? So everybody knows that scalar quantities are such quantities which require only magnitude for their propagation. So that is why, in the part A, displacement is a vector quantity. In the part B, momentum is a vector quantity. In part C, there is no vector quantity. Power is scalar, time is scalar, work done is scalar. So that is why we have to go with the option number C. In the question number three, he's talking about that a ball falls from rest through glycerine and reaches the terminal velocity. Which of the following graphs show how displacement varies with the time for the ball? So, initially the body would not be having any sort of terminal velocity. As it gains the velocity, there would be a time when the gradient of S and T should be very uniform. So that is why you have to keep it like, if you look at the option number A, the distance is constant, which means the body has a zero velocity and terminal velocity is not zero. So we're not going to go with A. Similarly, C is showing you a uniform gradient, but a body takes some time to reach the terminal velocity, so that is why we're not going to go with C. Same is the case with D because there is no uniform velocity. The only option that makes sense is B, right? So that is why we have to go with the option number B. In the question number four, a piece of a conducting putty is shaped into a cylinder of uniform cross-sectional area. The length is L and the resistance between the two ends is 8 ohms. So everybody knows that resistance is rho L upon A, and the value of resistance is given, and that is 8 ohms. And now the length has been doubled, and since we need to keep the volume constant, remember if you're doubling the length, your area should increase in such a way to keep the volume constant. So A times L is the volume. If you're doubling the length, you have to decrease the area by 2, so it would be V now. So now rho as it is, in place of length, I'm going to write 2L. In place of A, I'm going to write A upon 2 for the second one, right? For this one, keep it equal to 8 as well. And now I would be having, rho L divided by A times 4. Rho L upon A, the original resistance was 8. So, 8 times 4 has to be 32 ohms. So that is why I'm going to go with the option number D. Now you've got this option number 5. A car is traveling on a, in a straight line along a horizontal road. Which row of the table gives the Newton third law of pair of forces? So for this thingy, you have to go with the option number B, because they are the same forces acting on the different objects, which makes up the Newton third law of pair of forces, right? So that is why you have to go with the option number B. In question number 6, the diagram shows an electric motor pulling a truck of mass m along the slope. The truck moves a vertical height h and a distance l along the slope during the time t. There is a potential difference V across the motor and the current in the motor. So first of all, the the input power is going to be, the input power or even the input energy is going to be V times I times T. So that is the input. And the output energy by which this motor is pulling this mass up should be mg. And you can see that this mass is being pulled up by a height h. So you have to give it h. So the efficiency is going to be um, VIT, no, output, MGH divided by VIT. So that is why you have to go with the option number C. And now you have got this question number 7. A student investigated the EMF and internal resistance of the battery. The student produced the following sketch of the graph. Which row of the table gives the quantities plotted? So first of all, in the option number A and B, you've got this EMF. For example, this is EMF. And remember that EMF always remains constant. So that is why I'm not going to go with A. I'm not going to go with B. In the option number C, you've got the terminal potential difference and the circuit resistance. So, both are directly proportional to each other. So their graph could not look like this thingy. And now, but the D option, terminal potential difference and the current, it could be the only this thingy, terminal potential difference and the current. As you increase the current, the terminal potential difference decreases. So that is why you have to go with the option number D. Similarly, a ball is thrown vertically upwards at a velocity of 6 meters per second, which of the following gives the maximum height. So everybody knows that V square is equal to 2gh. You need to calculate the h, so V square upon 2g. Now you can see that the velocity is 6 square divided by 2 times 9.81. So that is why you have to go with the option number C. Did you get that? So that is how we're going to go with the option number 8. I'll be back in the next video, starting from the question number 9. Till then, thank you very much. That's it for today. Hello, this is Farhan Shakil from the Republic 2.0, and here I'm back with the guest paper for 2025 8 PHO edexcel physics. And in this guest paper, I'm just going to solve the May 23 paper. I've already posted the part 1 of this video having all the multiple choices. Now I'm just going to start with the structural problems, and here we go with the question number 9. In the question number 9, the examiner says that a student connects the circuit shown. The battery has negligible internal resistance. You've got 6 volt, 10 volt is the constant resistance, and there is a voltmeter around it, and then you have got a variable resistor. And then a student increases that resistance of the variable resistor from 0 ohms to 40 ohms. Determine the range on the readings of the voltmeter. So we just need to determine the range of the readings of the voltmeter. So what we're going to do first, when the resistance of the variable resistor at 0 ohm resistance, if the resistance of the variable resistor is 0 ohms, what does that mean? The voltmeter would show the whole of the total read, whole of the voltage. The total voltage is 6, so it is going to show 6 volts. But when this is going to be the maximum resistance, meaning thereby 40, we need to determine the voltage across it. So by using at 40 ohms resistance, I'm just going to use the equation for the potential divider. The total voltage is 6, right? The total voltage is 6 divided by the sum of these voltages, and that's going to be 50, is equals to, now I'm just going to talk about this voltage across 40. I'm going to keep it like V divided by the total voltage across it right now is something like, uh, across this one, across the voltmeter has to be 10, right? And now from this equation, V should be equal to 6 upon 50 times 10. And that gives me approximately 5, 1, and 6 upon 5 is 1.2 volt. So the maximum reading on the voltmeter that we can have is 6 volt. And the minimum reading on the voltmeter could be 1.2 volts. Now we'll get to the question number 10. And the question number 10 says that a model rocket accelerates vertically upwards, then decelerates due to gravity until it reaches the maximum height. The VT graph of the rocket until it reaches the maximum height is shown something like this. Show that the rocket reaches a maximum height of about 68 meters. So if you want to calculate the maximum height, that is a total distance covered by the rocket in the upward direction. And how you can get the distance from the VT graph by just calculating the area under the graph. You can see that this is some sort of a triangle. And if you want to calculate the total distance covered by the rocket or the maximum height gained by the rocket, you just need to use the formula half times base times height. Plus now we can see that the base is approximately if you kind of measure it down, the base is approximately 4.5. So you've got 4.5 times the height of the rocket is something like 30. And when you're going to solve it down, 2 times 15, 15 times 4.5 has to be something like 67.5 meters. So you can see that the total height covered by the rocket is approximately, what it was, 68 meters. Now we'll get to the next question. And when the rocket reaches the maximum height of 68 meters, the parachute opens, and almost instantly the rocket reaches a terminal velocity of 2 meters per second. Because it is moving down, so its terminal velocity has to be negative 2 meters per second. Right? Because it went to the maximum height, now it is coming back, so its velocity should be in a direction or a sign opposite to the original one. So you can see that right after 4.5 seconds, the parachute opens, and now a straight line would take you to the negative 2, and this would be negative 2. So this is the velocity. And everybody knows that terminal velocity has to be uniform, right? Terminal velocity has to be uniform. And if the terminal velocity is uniform, the body would keep on moving with a negative 2 meters per second square velocity. But we never know for how much time it would keep on moving. So, initially, first of all, if you think about it, we need to calculate the time of the descent, and the time of the descent can easily be calculated by just using t is equals to, since v is equals to d upon t, so t is equals to d upon v. The distance we just calculated was 67.5, the speed is 2. If you're just going to divide them up, you'll have 33.8. That is the total time of descent. And, it has to move, uh, cover up the height in 4.5 seconds as well. You can see that over here. So, the total time it's gonna take would be 38.5, not 33.5 plus 5 and plus 4.5, sorry. And that's gonna be 38.3. So the body would keep on moving with the negative 2 meters per second square velocity until we get to negative 38.3. And that should be something like over here, right? So that is the shape of the graph, and the parachute opens up and the body starts moving with the terminal velocity. In the C part, the rocket is fired upward a second time when the wind is blowing. The rocket falls with a vertical velocity of 2 meters per second. So it is falling with a vertical velocity of 2 meters per second and a horizontal velocity of 1.5 meters per second. Determine the velocity of the rocket by drawing a scaled diagram. So first of all, we've got 2 meters per second, and I'm supposing that, uh, you know, two boxes would give you, or we can say, two boxes represent, yeah, one big box represent 0.5 meters per second, right? So I'm just going to draw a curve, and that curve would look like, since the body is moving downward with a velocity of 2, so 1, 2, 3, and then it's going to be 4. So that is the downward velocity, which it would be 2 meters per second. And then after this thing, you've got 1.5 meters per second. So 1.5 would be somewhere over here. This is 1.5. And now this is going to be the resultant vector. How you can calculate the magnitude of the resultant vector? This is the hypotenuse. So you just need to do, 2 square plus 1.5 square equals to the resultant velocity square. Taking the square root, you would be having square root of 4 plus 1.5 is 2.25. If you're going to solve it down, you should have 2.5 meters per second. That is how you calculate the velocity. The magnitude of this vector has to be 2.5. And if you want to calculate the angle gonna be tangent theta is equals to opposite over adjacent TOA. Opposite is 2, adjacent is 1.5. So theta comes out to be tangent inverse of 2 divided by 1.5. And you'll eventually get, theta is equals to 53. And the magnitude of velocity is 2.5 meters per second. That is how you were supposed to do this question. Now you've got this question number 11. And in question number 11, the student investigates how the resistance of the length of the nichrome wire, right, changes with temperature. The student takes measurements to determine the resistance of the wire at different temperatures. Draw a diagram for the circuit student should use. Draw a diagram for the circuit the student could use. Which circuit diagram it could use. So first of all, you guys must have a battery. You know, so you must have a battery, something like this. Then you have got a circuit, and you have to go with the length of the nichrome wire changes with temperature, and you need to calculate the resistance of the wire at different temperatures, right? To determine resistance of the wire at the different temperatures. The student is investigating how the resistance of a length of nichrome wire changes with the temperature. So what else do we need? We need an ammeter to calculate the current. Then we would need a nichrome wire. This is, let's suppose, be a nichrome wire. And plus the resistance of this nichrome wire can be calculated by using an ohm meter as well. So we have got this ohm meter. And then, yeah, that's it. Plus, we need a voltmeter connected in parallel with the nichrome wire. Got it? Ji? So what would happen? The ohm meter gonna give you resistance, and this current and the voltage would give you an idea about the different temperatures. So by varying the current and the voltages, you can vary the resistances as well, right? That is how the diagram you can use to calculate the effect of resistance upon temperature. Now, in the second part, the wire has a thin electrically insulating coating so that it can be coiled up without causing a short circuit. The student places the coil of water into the water bath so the temperature um so we need to describe how the student could determine the temperature of the wire accurately. Okay? How can the student determine the temperature of the wire accurately? So what he gonna do? He can use the temperature of the water with the help of a thermometer. So what he's gonna do? He's just gonna place that wire into the water, and then he can just stir the water for the uniform spread of the temperature. And once the temperature is spread uniformly, he can just use the thermometer to get himself the final temperature. So first of all, what you're going to do, the first point that he can use a thermometer, right? And with the help of thermometer, he can just dip it in water. Secondly, what he can do, he can just stir the water, right? Stirring the water would help you to uniformly, spread out or elongate the temperature. So stir the liquid or the water, and then thermometer. You should be placing the thermometer near the coil as soon as you're done with it, right? So that is a second alarming. So these are the three steps by which students can measure the temperature quite accurately. Now, in this B part, explain in terms of the particle behavior that why the resistance of the nichrome wire changes as the temperature changes. So first of all, we just need to talk about that why the resistance of the nichrome wire changes as the temperature changes. So what we know, as the temperature increases, kinetic energy of particles increases, kinetic energy of the particle increases, thus increasing the frequency, hmm, sorry, frequency of collision of electrons. And as soon as the frequency of collision of electron is increased, drift velocity, collision is going to oppose the actual flow or actual vibration of the electrons. So drift velocity going to decrease. Drift velocity would decrease. So the current, right? The current would decrease. And as soon as the current going to decrease, the resistance of the wire going to increase. So you need to mention these 4 points while talking about this 4-marker question. Now, next, we've got this question number 12. A wire wound resistor consists of a long length of wire wound around an insulating core. A technician finds a wire wound constant N resistor labeled 80 ohms. Calculate the length of the constant N wire using the used to make the resistor. So we just need to use R is equals to rho L upon A, and now this equation would become L is equals to R A upon rho, right? You have got the resistance. The resistance is 80. You've got the diameter, just convert it into the radius, and calculate the area. It's gonna be pi times 0.14 times 10 raised to the power of minus 3 square. So this is 80. 80 times pi r square divided by the resistivity, and the resistivity gonna be 4.9 times 10 raised to the power of minus 7. That is how you can easily calculate the resistance. So you've got 80 times pi times r square divided by 4.9 times 10 to the power of minus 7. That is how you'll get the resistance. You'll get the length, right? By just plugging all of these values in the calculator, you would be having the final answer as something like 10 meters, right? Now you've got this question number B. A potential difference of 9.8 volts applied across the resistor, and current in the resistor is 0.1212 amperes. Deduce whether the value labeled on the resistor to support these data. Uncertainty in the potential difference is 0.1 volts. Uncertainty in the current is plus minus 0.01. The labeled resistance on the resistor was 80 ohms. So we just need to check that by having resistance from these calculations, would it be in this range or not? So first of all, what you're going to do, you just need to calculate the resistance, and the resistance comes out to be, whenever you're talking about the resistance comes out to be 9.8 divided by 0.12, which is basically 82 ohms, right? If you want to calculate the resistance, the total percentage uncertainty, that gonna be, you can see that, first one of them is 9.8 was the voltage. The uncertainty in the potential difference is 0.1. So 0.1 divided by 9.8 multiplied by 100 plus 0.01 divided by 0.12 multiplied by 100. If you just solve them down and, if you're just going to add them up, you should have 9.3%. So this resistance is there with a percentage uncertainty of 9.3%, right? Now the 9.3% of 82 going to be something like, for example, if I talk about it, 82 minus 9.3% of 82. That comes out to be 74. So 74 is the lowest estimator of the resistance. But the resistance marked on the resistor is something like 80 ohms. So this is adjustable, right? So that is how we're going to go with this resistance. Is that clear? Now we've got the next question, and that is question number 30. Some students use a plank to make a bridge across the stream. The plank rested on the rock as well as the wall. This is the wall, this is the rock. Assume the plank is uniform. Show that the weight of the plank is about 250 Newton. So if you want to calculate the weight of the plank is 250 Newton, just use W is equals to mg. So you would have the final answer. M is 25 times a G has to be 9.81. So you're just going to times them up and you'll get the final answer. And that comes out to be something like 245 Newtons, right? Now, in the B part of the same question, you need to determine the force exerted by the wall on the plank. You need to determine the force exerted by the wall on the plank. So I'm taking this as a point of pivot, right? So there are two forces acting across the pivot. That is the weight of the plank itself and the upward force on the plank by the wall. So I'm just going to use the principle of moments. If I'm talking about the weight of the plank, it has to be 245. The moment due to the weight of the plank should be 245 times. The total length of the plank was 5 meters. It must be acting at the center of gravity, so you were going to use 2.5. We're going to keep it equal to the upward force exerted by the wall, and that has to be something like F times the distance between the wall and the rock itself is something like 5 minus 1.4, which must be whatever it is. 5 minus 1.4 has to be 3.6. So by just using F from here, 245 times 2.5 divided by 3.6, you'll get the final answer. And that final answer is going to be 174 newtons. So that is how you can get the force exerted by the wall on the plank. In the B part of the same question, a student weighs 550 Newton states that the plank will tip if she walks from the rock to the other end of the plank. Yani her weight is 550, and she's just telling us that it would tip when she's gonna move from the rock to the wall. So first of all, if you talk about if she is walking from here to here, from here to here, and for example, by walking from here to here, for example, she reached at the wall, something like this, right? Let this point be the pivot, and you can see that if this point is the pivot, the weight, that moment of that girl gonna be 550 times 1.4, 550 times 1.4, and that comes out to be 717 nanometers. Got it? Now, moment due to weight. Moment due to weight is going to be, weight was 245, right? Times, if we consider that thingy, the distance from that pivot should be 2.5. Total, it was negative 1.4. If you just work it out, you will have 270 nanometers. So you can see that 770 is greater than 270. So the student was right. The plank would tip, right? Based upon the conservation of the moments on both the sides. Since the moments, anti-clockwise moments is not equal to the clockwise moments, so the plank, there is a very high probability that a plank would tip, right? So we're done with 13 questions of this paper, 23, which is also a guest paper. This is a part 2 of the video, and I'll be back in the next video, starting from question number 14. So stay tuned. Thank you very much. Hello, this is Farhan Shakil from the Republic 2.0, and I'm back with the part 3 of the edexcel 8PHO/01 May 2023 paper. In the last part 2, I've solved almost the first 13 questions of this paper. Now we'll restart from the question number 14, and the question number 14 is right on your screens. So question number 14 says that a student connects a filament bulb to a battery. The battery has internal resistance. The student connects an identical bulb in parallel with the first bulb, right? With the first bulb as shown. He continues to connect identical bulbs in parallel. The student observes that the bulbs get dimmer as more bulbs are connected. He also observed that the temperature of the battery increases. So we need to explain these observations. So first of all, if you guys remember, before I get to the answer of this question, he is connecting all these resistors in parallel. If he's connecting all these resistors in parallel, and we do know that the parallel uh, total combination is R1 times R2 divided by R1 plus R2. In simple words, as you connect the resistors, as you connect thingies in the parallel, the resistance keeps on decreasing, right? That is the main point of this question, which we need to keep in mind. Okay, so we'll start with the first point, and the first point should be that as the student keeps on connecting bulbs in the parallel, the resistance would keep on decreasing, right? The resistance, first point is going to be that the resistance of the circuit keeps on decreasing. That is the point number one of this thing. And the second thing, as the resistance decreases, what does that mean? That the current in the battery increases, because resistance is the opposition to the flow of current. If it is decreasing, what does that mean? The current in the battery keeps on decreasing. Similarly, in the third point, we can talk about like the potential difference, right? We can talk about the potential difference. The potential difference across the battery or the internal resistance, potential difference across the internal resistance or the battery would increase as well. And as the potential difference across the battery going to increase, the terminal potential difference of the battery going to decrease. Same as the thing, by just using E is equals to V plus IR. By using this formula, we can eventually say that the terminal potential difference would decrease. And as the terminal potential difference would decrease, so bulbs would glow dim, right? In the fifth place, when you're talking about it, what does that mean? If you're having a less terminal potential difference, what does that mean? That the energy transferred from the battery would somehow, increase. Energy transferred from the battery would increase. And as you're going to increase the energy transfer from the battery, on the sixth point, we need to remember that the thermal energy, would increase in the battery. So, these are the simple points which we need to mention for this question. He was just talking about that why the bulbs got dimmer. And, the bulbs got dimmer when as you keep on connecting the resistances in parallel. Now we'll get to the question number 15. And in question number 15, the bullet of mass 12 grams is moving at a speed of 450 meters per second. The bullet hit a soft wooden block of mass 2.5 kilogram, which was attached to the wire as shown. The bullet becomes stuck in the wooden block, which swung upward. Show that the momentum of the bullet is 5 kilograms meters per second. So yeah, that's quite easy. P is equals to mv. You can see that your mass is 0.012 kilograms and your velocity is 450 meters per second. You're just going to times them up. And after multiplying them up, you would simply be having something about 5.4 kilograms meters per second, which is about around 5. Similarly, determine the maximum change in the vertical height of the wooden block. Now we need to calculate the maximum change in the height of the wooden block. So as you know that the kinetic energy of the bullet would translate into the potential energy gained by the wooden block. So that is why using the law of conservation of momentum, we can keep the kinetic energy equals to the potential energy. M and M gonna cancel out. And since you're looking for the height has to be, V square divided by 2g. Now I'm just gonna plug in the values. You've got the speed. If you remember the speed of the thingy, well, first of all, yeah, we do not have the speed of the, what do you call it? The wooden block. So first of all, we need to calculate the speed. And speed gonna be the momentum translated was 5.4, right? And the total mass, because the bullet was it was somehow was ingrained inside the wooden block, so it has to be the total mass has to be 2.5 plus 0.012 times v. We can calculate the v from here, and v comes out to be 5.4 divided by 2.512, and by just dividing them up you got to yourself something like 2.1 meters per second. So that was the velocity gained by the block. So by just plugging that value over here, I would be having 2.1 square divided by 2 times 9.8. And when you're going to solve it down, you should be having the final height as something like 0.24 meters. So that is the maximum change in the height of the of the wooden block. Now, in the part B, the soft wooden block was replaced with a hard steel block of the same mass, right? An identical bullet was fired at the steel block with the same speed as before. The bullet rebounded from the steel block. Explain why the steel block moved through a greater maximum vertical height than the wooden block. So first of all, we need to talk about that why the steel block could move a greater maximum vertical height than the wooden block, right? So first of all, since the bullet final momentum turned out to be negative, since the bullet final momentum was negative, one can conclude that it had a greater change in momentum because it somehow moved backwards, right? And somehow when it moved backward, what does that mean? So delta P, change in the momentum of the steel ball. Change in the momentum of steel ball would also be higher as compared to the wooden block, because if the momentum has to be conserved, and the bullet is moving back, what does that mean? The steel should be having a higher momentum as compared to the wooden block. And since if it is having a higher wooden block, what does that mean? That it should be having a higher initial velocity. And if it is having a higher initial velocity, what does that mean? It must be having a higher kinetic energy. Higher kinetic energy means large gain in potential energy. Higher kinetic energy means a large gain in the potential energy. And higher potential energy means, if you've got a higher potential energy means greater height gained, right? So that is why the steel ball moved a greater height as compared to the wooden block. Now we have got the next question. And the next question is that student released a trolley from the top of a ramp of length of about 1.5 meters. As shown, the student investigated how the speed of a trolley at the bottom of the ramp varied with the height of the ramp was increased. The student placed a light gate connected to a data logger at a position A to measure V as the car passes through the light gate ramp. How would you measure, that's quite easy. How would you measure the H accurately? First of all, if you want a very usual or a common way to measure out this height, you can use a meter rule. But if you want to be very accurate and you want to keep your ruler exactly vertical to calculate this height, you should be using a set square. Since it was also a two marker question, so that is why I'm giving them two instruments. Meter rule has a less accuracy as compared to the set square, because with the help of set square, you can keep your ruler exactly vertical in the direction of H. Now the B part. The student derived the following equation for the motion of the trolley, where G is an acceleration due to the gravity. Explain why plotting a graph of H against V square will produce a straight line. Well, if you could just compare this equation, H is equals to V square upon 2G, compared with the equation of the straight line, which is Y is equals to mx plus C. So we can also write it like this: H equals to 1 upon 2G times V square plus 0. So what does that mean? Whenever you're going to plot H and V square, you should be having a straight line with a gradient 1 upon 2G and with a y-intercept at 0, right? Meaning thereby your curve must be passing through the origin as well. So it should be a straight line. You can see that. I've compared it with a straight line equation. The student varied H and measured corresponding values of V. The results are recorded below. You've got this H, you've got this V. Plot a graph of H on y-axis and against V square on the x-axis on the grid opposite. Use an additional column in the table for your processed data. So that's quite easy. You just need to take the H on the y-axis and you just need to take the V square on the x-axis, and you would be having a very straight line. I'm not plotting a graph. You know, I'm just drawing a superposition data. So it must be a curve like this, right? With H on the y-axis and V square on the x-axis, right? That is how we're going to plot this graph. In the part 3, the student used her result to plot a graph and determine the value of G. She concluded that her value was consistent with the value of G given on the data sheet at the back of this paper, which is 9.81, of course. Comment on the student's conclusion. How can you, conclude these, how can you conclude these statements? So how the student might have, calculated the value of G, since he calculated the graph between H and V square. So she must have calculated the gradient, which was equals to 1 upon 2G, right? For example, if she's having a gradient M, which is X, which could be anything. And how can you find out the gradient? By using different methods. You can use a large triangle. You can use a tangent method. You can use the 2-point form, right? And whatever method you're using, you'll be having X. X is equals to 1 upon 2G. So swapping X and G, you would end up having G is equals to 1 upon 2X. And by just multiplying the gradient by 2 and taking the reciprocal of it would get you the G. Is that clear? That is how we're going to get the value of G. And it must be somewhere in between, 9.5 or 10 or 10.1 or something like that. It must be fine. Okay, now we have got this question number 17. And in question number 17, what we're going to do, a lift is positioned at the first floor of the building. It is suspended by 6 identical steel cables of length 50 meters. Calculate extension in each of the lift cable. Extension means we need to calculate delta X. Cross-sectional area of the cable is this thing. Young modulus of the steel is 200 gigapascals. And then we have got the weight of the lift as well. And that weight of the lift is this thing. So how can we calculate the extension if we are having a strain? But the thing is that we do not have the strain, right? And if we do not have the strain, we cannot calculate the extension. So first of all, I'm just going to calculate the stress, which is F upon A. I've got the force, which is going to be the load of the weight, which is the weight, and that's going to be 12 times 10 raised to the power of 3 divided by the cross-sectional area, which is 3.1 times 10 raised to the power of negative 4. I'm just going to divide them up, and I would be having 6.45 times 10 raised to the power of 6. That is how you're going to get yourself the stress. Now, I'm going to talk about the Young's modulus. So the Young's modulus is going to be the stress upon strain. You've got the stress that is 6.45 times 10 raised to the power of 6 divided by the strain. So the strain is going to be 6.45 times 10 raised to the power of 6 divided by the Young modulus. The Young modulus is 200 gigapascals, yani 10 raised to the power of 9. By just calculating it down, I would be having 3.23 times 10 raised to the power of negative 5. That is how we're going to calculate the strain. At the end of the day, I'm just going to talk about the strains. Strain is delta X upon X, the original length. So the extension comes out to be original length times the extension. Now, if you think about the original length of the cable was 50 meters. So 50 times the strain, and the strain is 3.23 times 10 raised to the power of negative 5. And I would be having 1.61 times 10 raised to the power of negative 5 meters. So that is the extension we're looking for. Okay. Now, calculate, the 10 people enter the lift, right? 10 people are entering the lift, move upwards and stops at the top floor of the building. The graph shows the total tension forces in the cable during this time. So you can easily see that, uh, you know, 10 people enter the lift. 10 people, is the number of people that the lift got. The weight of the lift is 12 kilonewtons. If 10 people entered into the cable, the weight or the tension acting in the cable comes out to be 19 newtons, right? 19 kilonewtons. So what does that mean? The total weight of the people is going to be 19 minus 12 kilonewtons. And that comes out to be 7 times 10 raised to the power of 3 newtons. Once you've got the weight of the people, what I'm just going to do, I'm just going to calculate their masses. So masses of the people going to be 7 times 10 raised to the power of 3 divided by 9.81, and it comes out to be 714 kilograms. So 714 kilograms is the mass of the people. Explain the motion of the lift between 5 seconds and 29 seconds. So we just need to explain the motion of the wave between 5 seconds and the 29 seconds. So you can see that the 5 seconds starts it from here, and until we have got something like, this is uh, 6.5. So this is going to be 6.5. So from 5 to 6.5, there was a resultant force acting upward on the cable, right? So first of all, I'm just going to mention that from 5 to 6.5, there is a resultant force acting upwards. You should not write it like this. You just need the resultant force acting upward, a very good line. And we've got that. Now from 6.5 seconds to 25, 26, 27, 27.5. So now you can see that from 6.5 to 27.5 seconds, there is no resultant force acting on the cable. You can see that the wire is constant. And as soon as you reach 27.5 seconds, so 27.5 seconds, we were supposed to explain it up till 29, until 20 seconds, there is a resultant force acting downwards on the thingy. So there is a resultant force which is acting downwards. Got it? So that is how we're going to talk about it. Now, when the lift is empty, a technician removes one of the cables for the maintenance. Assess how removing one cable would affect the extension of the remaining cable. Well, that is for sure. If you're going to remove one cable, what does that mean? Tension, upward force or the downward force acting on the cables would increase. So tension would increase. And as the tension gonna increase, what does that mean? The forces has been increased. So what does that mean? That the stress would increase as well. Stress would increase it as well. And as the stress increases, the strain of each in each cable would increase. So the extension would be greater. So you would be having a greater extension by having a higher stress as well. So that is what we're going to do. And that is it. We're done with the 23 past paper of AS level at Excel. Thank you very much. I'll come back with the next video on the same YouTube channel.